Okay, I want to start today's lesson with talking about reflections that happen on the inside. If we have a negative on the inside, I think you know that that means a left-right kind of reflection. Like if you had a picture that was this simple, if I had a V that was like that, you know how to reflect that left-right, don't you? So you just take this piece and you'd reflect it across, and it would now be over there because you're reflecting it across the axis this way if you have a negative on the inside. So how do you do that with cosine and sine? Well, really what it boils down to is you on one of them, when you do the reflection, nothing changes at all. And on one of them, when you do the reflection, then you have the same thing as if you'd reflected it up down. Okay, so let me show you. Here's sine. You might want to take notes on this. This is sine. Here's sine with a negative on the inside. I'm going to graph it in green. I want you to think through, if I'm reflecting it left-right, do you get, if I just take this part of the graph that I graphed and reflect it left-right, that it would end up looking like that? Let my axis go a little further in blue there. Do you get that that would be a left-right reflection of sine? But you don't have to go graph it over here, from here to here. You can continue with it in the same interval that you were in. In other words, you can leave your graph in this area. Now watch what happens if I extend this out. I think you'll see the left-right reflect happening here, but this next part will probably blow your mind. If you extend this out, that's what sine looks like now. So sine's one of those weird functions that when you do an up-down flip, it's the same result as if you did a left-right flip. So I'll give you an example. You had one like this before. Do you remember this guy? 1 over x? It's one of the top 12 big precalc functions. Okay. When that one gets flipped up-down, do you get that it goes like this and like that? Do you get that it's the same exact thing if you'd have flipped it left-right? So a left-right reflect and an up-down reflect come out in the exact same place. So does sine. Okay, so if you ever are asked to do sine of negative x, it's the exact same thing as negative sine of x. You put a negative in the front or you put a negative in there, it comes out the same. Not the same as original sine. You know, the original sine is in red here. This one is original sine. Original sine is different, but if you do a negative on the inside, it changes in this line right there, and you do not make it dotted. I'm just trying to make a point that it's been flipped. Okay, so that's sine. When you do a reflect on sine, it's the same exact thing as a up-down reflect. Left, right, and up-down are the same reflect. On cosine, here's cosine. Oh, that's not cosine. Hold on. I'll do a different color here. Cosine's like a big valley. There we go. Okay. So cosine, if I do a left-right reflect, do you get, if I reflect this, do you get when I reflected cosine, left-right, nothing changed? You know what I'm saying? It's on itself. It's on top of itself. So if this is regular cosine, the red one, not cosine x, 0 s x, okay, compared to this one's cosine with a negative on the inside, it's like nothing happened. So in other words, if you have a negative on the inside on cosine, you don't do anything. You do leave cosine alone. Is there a precedence for that? Yes, we've seen that before. Do you remember x squared? Little parabola, right? Do a left-right flip on that and see what happens. Nothing changes. You know what I'm saying? Okay, so this has happened before. It's not like this is unheard of. But cosine, if you have a left-right reflection on cosine, you haven't done anything. So it would be a safe thing to say that cosine of x is equal to cosine of negative x. It doesn't do anything to reflect it left-right. Okay, so let's say you're going along in a course of one of your test questions, and it was about this, for cosine of negative 2x. Everything means something except for that negative on the inside. Do you get in the case of cosine that doesn't do anything? All right. Would you have to still list it in your list of things? Yes, you would. But it wouldn't actually, when you graph it, wouldn't do a thing. All right. Let's see if you know some of the test kind of questions. This is just a little bit of review. The big day of review is tomorrow, but what's the amplitude on this thing? 4. It's just the number in front. What if it had been negative? Would that have mattered? It's still an amplitude of 4. Now, what about, would it matter to the picture of the graph? Here's regular cosine. What if I throw a negative in front? Does that matter? Yes, that's an up-down flip. They matter. This matters. This does not matter. Okay. So this makes it go like this. I messed that up kind of, but close-ish. All right, so I'd like to ask you a couple other questions. I'm going to give you a simpler one. What is the period of this one? What is the amplitude? What is, let me think, and what does the graph look like? You should be able to graph this one. Use the 4 important numbers on the x-axis. Pause for a second while you try that one. Okay, it seems like you guys finished up talking about it. So basically, I heard a lot of people saying the period is 2 pi over the b, which is 2/3. That is correct, but is there a better way to write it? Yes, you should simplify that. You have to reduce things as much as you can. So instead of dividing by 2/3, I would suggest you take the 2 pi and times it by 3/2. Then the final answer would be 2 pi over 1 times 3/2. Again, I almost wish we did this, instead of the formula being 2 pi over b, I think maybe it'd be like easier for you if we said the period is 2 pi and then instead of over b times 1 over b, and then if the b happens to be something simple like 2, it'd be times 1/2. And if the b is something like 2/3, you'd have divided by 2/3. And then you'd have to know, oh, 1 divided by 2/3 is the same as 3/2. And then you times it by 2. So anyway, final answer, 3 pi. How many of you had 3 pi? All right, okay, good. On this next one, amplitude. Amplitude is just the number in front, and it's the absolute value of it. So if there was a negative in the front, that wouldn't affect the amplitude. The amplitude is 3. And just to clarify, that means that it's not the total swing. If the total swing here was measured, it'd be from -3 to 3. The total swing between the high and the low points is 6. The amplitude's half of that. They're going to ask you that in some of the questions today in today's homework. They're going to say the total distance from the highest point to the lowest point is 10. What's the amplitude? And what would you say? 5. If the total swing between the highest and lowest is 10, you take half of that to get the amplitude. Okay, so the amplitude is 3. It's not this total, which would be 6. It's half of that. Okay, and then the last part is the actual graph. I would recommend you start by numbering it the normal way. 2 pi and pi over 2 and 3 pi over 2. That can be your happy place. You always know those. Then you go through and multiply everything like just like we did here, times 3/2. Times 3/2, times 3/2, times 3/2, times 3/2. And then you'd have 3 pi over 4, 3 pi over 2, 9 pi over 4, and the last one is 6 pi over 2, which reduces to 3 pi. Okay, and the actual picture, well, if you know what cosine looks like, you know what the picture looks like. It starts up high, and it ends up in the same exact spot, and then over in the middle here, it's at its lowest spot. And then it goes kind of like that. There we go. How many of you are feeling comfortable with that kind of topic? Okay. Now, if you're not, then I'd be happy to work with you during break time, during work time today, when you'll have some time to work on your homework. All right, so the new stuff for today, it's not that. The new stuff for today is like this. What if we had sine, and there's a number in here, but it's not the b term? What if it's x plus pi over 2? This is not a stretch. Think about this for a second. It's kind of like this. What if we had x squared, but then I throw in something in with the x, and I said something like this, plus 3 squared. Do you get that this moves it left 3? Well, it's the same exact thing. This moves it left a distance. The distance happens to be pi over 2. So this means left pi over 2, and that's called a phase shift. I've shifted the whole thing to the left, pi over 2. Now, how would that actually look? I want you to, everybody, make me a nice, clean sine graph. Here's sine. Make one of those. And in a moment, I'm going to ask you to grab just the sine wave, and you're going to actually grab it and move it over with your scissors, because your iPad's good at this. We can slide the thing to the right with your little scissors tool by grabbing it. Okay? So for me, it's all going to clump together. So I'm going to redraw it with different colors so that I can grab pieces. All right, so it's like this. Here's my sine wave. I have to move it over to the left, pi over 2. So obviously I'm going to grab it, move it left. But how far do I actually move it? Well, I need to have it numbered so I know how far pi over 2 is. So if you've got these spots labeled, you should know that pi over 2 is that spot, and therefore this is how long pi over 2 is. That's how far we need to move this. 1 notch to the left. So how do I move the whole graph 1 notch to the left? I would think of it as grabbing the tail right here, and you're going to just move that dot along with the graph 1 spot to the left. Oh, you didn't stick to the tail, but there we go. See? I just moved sine 1 notch to the left. And doesn't it look a lot like cosine? And it is. Cosine and sine are the same shape, just shifted. Told you that at the very beginning. So sine of x plus pi over 2 is actually cosine. It's identical to cosine. Okay. So, that was left, moving left. It would obviously be pretty easy to just change this to a minus, right? And then I'd just take the parent graph, which was back over here, and move it pi over 2 to the right now. If there's a minus in there, it just means right. Pi over 2. So I grab the whole thing, move it right to pi over 2. There we go. Is that dot at the end really necessary? No. But it's just hard for some people to visualize how far am I moving it. And if you just move the dot over 1 to the left or 1 to the right and make the graph match it, it's sometimes easier for people. Okay, so how do they get any harder? They get harder when they do this. I didn't need that fraction bar. If they ask you to do this, it's not incredibly hard, but it's not just moving it to the right pi. It is not to the right pi. The phase shift then goes like this. I'm going to rewrite this. You see if you follow me. Do you get what I'm doing here? I'm factoring the 2 out. Because the 2 is the b term, and it's important, but it messes with my phase shift. So I need to factor that 2 out. So how do I factor it out? I got to ask myself, well, 2 times the x will make 2x. I'm good there. 2 times what would make pi? Pi over 2. Now the phase shift is clear. The phase shift is this part. Right pi over 2. So this depended on factoring. You need to be able to handle factoring to be able to handle this. All right, so let's factor a few of these. So we're going to start with something like this and factor it to be something like that. All right, try this one. Cosine of 3 pi minus pi over, let's just keep it simple and just say 3x, sorry, minus pi. After you've got it factored, you'd be able to answer the question, what is the phase shift? That needs to go on my desk. So the 3 comes out. First part's easy. 3 times what makes 3x? Gotta be an x. Gotta have a minus. The only hard part's that last thing. Then you gotta ask yourself, 3 times what would make pi? I need a pi in it, obviously, but 3 times pi wouldn't make pi. Pi over 3. There we go. So the phase shift is right pi over 3. Also known as 60 degrees, but we're going to pretty much be used to using radians by now. How many of you had that one right? Most of you, not all. Let's try another one. Sine of, this one will freak you out a little bit. 1/2 x minus pi over 2. Factor the 1/2 out. Mr. J in the back row, how do I start? Minus or plus? Okay. Just pi? How can you prove you're right now? Multiply it out. Tell me what you get. That times that makes, see, and then 1/2 times the negative pi makes negative pi over 2. That's how you can prove that you were right, and you were right. So this was move it right pi. That's the phase shift. Sometimes we abbreviate it PS. The PS on this is phase shift. The P is the period. You're not going to, if there's ever that on the test, you can ask me, what's PS again? Phase shift. But I won't tell you how to do it. The key is on the harder ones, you got to be able to factor that number out. All right, so here is a typical test question then. I'm not saying, okay, typical question that summarizes this whole thing. I'm not saying this test is answers on the test or anything like that, but let's say it was like this. And they might ask you, is this function moved up or down? Is it moved up or down? It's moved up. How far? Up 7. Okay. Has this function's period changed from 2 pi that it starts at originally? Yes, it has, because there's a b term. Which of these numbers is the b? That's the b. Okay. So if I want the period for this function, then you're going to use 2 pi over that. If I want the phase shift, you're going to have to factor out the 2 and get this thing factored in there. If you want the amplitude, that's easy. It's the number in the front. Let me pause for a second while you try to answer those 3. Okay. Would you please compare with yours with the kid next to you that I paired you with? See if you get the same thing. Amplitude's in the very front. There's no number in the very front. See what I mean? Straight up there.
Would you put it as negative?
Nope, because it's the absolute value of that. So there is no, think about it this way. When you drew sine, do you get this not stretched at all? That negative flips it, but it doesn't stretch it. There's no stretch, then the amplitude is just 1. So the amplitude's 1. And then see if you can factor that 2. Oh, it looks like you did. Awesome. So then what's the phase shift? You almost have it. You just write that down. That's the phase shift right there. You say right. Yep. Right. All right, so now, here's your period. The period's 2 pi over b. What's the b term? 2. So there we go, 2 pi over 2. Should it simplify it? Yeah. What's 2 pi over 2? It's just pi. Okay. So the period on this is pi, which is shorter than it used to be. It finishes up by the time it hits pi. It used to finish up by the time it hits 2 pi. Okay. The phase shift, that's the new thing. Do you get the 2 factors out and you have x minus, and then you got to figure out the hard number after that? What is that? Pi over something. Pi over 4? All right, so how do I know if I'm right? I multiply it back out. 2 times the x makes 2x. 2 times the pi over 4 would make 2 pi over 4, which is the same as pi over 2. So yes, that's right. So then what's the phase shift? That part, which is right. You don't say negative. You say right pi over 4. The amplitude. I know that some kids could easily think that the amplitude was 2 here because they look at that. That's not where you should look for the amplitude, though. The amplitude is the thing in the very front. And if it's negative, you don't include the negative. So it's the absolute value of it. So think about this. If you graphed sine here, you're graphing it like this, you wouldn't stretch it. You wouldn't change these numbers. You know what I mean? It doesn't get stretched, so the amplitude is still 1 on this one. Who of you would have had all of those parts right? Awesome. And here's the last thing you have to know for today. If I just tell you the sinusoidal function, don't be scared, it's just the sine function. Okay? A sinusoidal function has a maximum of 8 and a lowest spot, or a minimum, of 2. All right, just for a second, sketch what that would look like. I know this is weird. It's oscillating back and forth where its highest spot and lowest spot are both above the x-axis. It's not dropping below the line. So lowest spot's 2, highest spot's 8. You with me so far? Then the question would be, what is the amplitude? The most common mistake answer, what do you think? The mistake answer, 6. Because people think, oh, the difference here is 6. And it is 6, but that's not the amplitude. The amplitude is half of that, so therefore 3. How many of you knew it was 3? Okay, good. All right. That's pretty easy. All right, so now let's actually do some from the worksheet. So let's start your worksheet together. Everybody find worksheet 4.4.3. 4.4.3. It looks like this. Now, I feel like there's a few too many questions on here. I mean, it's great. I love having the questions in case I need them, but I can trim it down a little bit for you, I think, and you'll be just fine. So, given how much time we have left in class today, I'm going to have you skip 2, 4, 6, and 8. 2, 4, 6, and 8. Let's see. You can skip 10. And 12. What the heck? I don't know if I should just do all odds, though. You know what? I think I can. I think that's reasonable. Just 2 odds. No, you weren't mind controlling me. I could hear you. But I was doing my own decision. All right. So here we go. On the odds. Number 1. So it's supposed to graph sine, and then I'm supposed to shift it plus, whatever that means. Is that left or right? Left. How far? Pi over 2. So if I were you, I would graph your parent one just like normal, and you're going to use that cool feature of your iPad, the Notability app in particular, that you can use the scissors and then move and slide your sine graph. Okay, so here's the normal one for sine. It goes up and down to 1 and -1. These 4 are the important marks. pi over 2. And if you want to count them up from the bottom, I don't usually do that, but you can. 2 pi over 2, which, by the way, is the same as pi. 3 pi over 2, and 4 pi over 2, which, by the way, is the same as 2 pi, right? You wouldn't want to leave them that way because those are not reduced all the way, but that's a way to do it. Okay, and then my sine graph goes like this. It goes up to 1 and down, and then ends at 0, just like it started. Okay, there. But now I got to shift it left pi over 2. How far is a pi over 2? It's one of those, where on the graphing paper, it's 2 marks. But I hope you get what I'm talking about. It's this far. That's how we got it far. We got to shift it left that far. So if I grab it, now you can do the same thing with your little scissors tool and move it left like this. Notice sine has just become cosine. That's what happens if you shift sine to the left. You've got cosine. Just grabbed it and moved it left. Now, one thing I'd have to do, any place I have graphed, I have to label. Do you get then that this spot right here doesn't have a label and it needs one? Tell me what it is. Negative pi over 2. Very good. I don't have to change any other labels. I just have to add a little bit of label underneath where I moved it to. Okay? This was much more of a pain when kids didn't have the iPad to draw on, if you had to do it on paper, because you have to erase and redraw the whole graph, which is much harder. Okay. Now, what if it's a test and you don't have an iPad to do it on? Well, then you just have to grab each point on the graph and move it exactly one spot to the left. So if that were the problem right now, I'd say, okay, I got to take this spot and move it one notch to the left. I got to take this spot here and move it one notch to the left. You get what I mean? And so then I'm going to say, okay, so then I reconnect all my dots. And I can do it, it's just definitely harder. Okay. Now, is there questions about it? Yes. It says, state the domain, range, amplitude, period, and phase shift. Domain. For sine and cosine, it's always all reals. Really simple. Range. How low to how high? We didn't mess with the low and the high because there's nothing up in front. So it's still -1 to 1. The amplitude. It's just a number in the front. There's no number there. So there's a 1 there. So it's 1. And the period? The period is, well, 2 pi over b. b is just 1, so it's still 2 pi. Don't let the fact that it has been moved a little bit think you changed the period. It didn't. There was no b term. There's no number there. And the last one is the phase shift. That's what the whole new thing is about. PS, you can abbreviate that, and that's this. And don't say plus, you say left pi over 2. I'll leave those up for another 10 seconds. Okay, now we're going to move on. Let's do one of the harder ones. The kind where you have to factor something like that one. First thing I would do is factor it. You know this is about phase shift, right? So I do this. 2 comes out, and you have what left? X. Who's got it? Say if you know it. That's pi. All right, now how do I know if you're right? Because I go 2 times x makes 2x, and 2 times the pi makes 2 pi. Yeah, you must be right. Then now I know my phase shift. Phase shift is right pi. My period, 2 pi over b. Is there a b term? Yes, there is. The b term is 2. So it's 2 pi over 2. So that's just pi. Amplitude, and there's no number in front. So it's 1. And was there something else? I feel like there is. Oh, period. No, I already. Domain and range. Domain, all reals. And range, since we didn't mess with this, it's still from -1 to 1. It needs brackets, by the way. I think I put parentheses on the last one. I just realized. So make sure you have brackets on your ranges because it touches the lowest and the highest spots. All right, now let's move to one of the problems at the end that's got that different style where it tells you the minimum and the maximum. Okay, and we're doing odds, right? So on number 17, a sinusoid basically just means it's a sine graph. Or it could be cosine because that's just sine being shifted. So really, in the end, any cosine can really be a sine. Anyway, so we're supposed to know what the amplitude is. If it looks like this, it's a wave where its lowest is 5 and its highest is 11. There, I got a little picture for you. That'll make it a lot easier. What's its amplitude? And please don't just subtract 11 minus 5. It's 3 instead. 11 minus 5 is 6. The amplitude is not 6. That's 6, but the amplitude is half of that. So it's 3. All right, now they do ask you a couple others that I did not show you yet, and let me help you with 21 because that's another valuable kind. It has a max of this and a next max at that, but it doesn't ask you, like the last one did, what the amplitude is. It says, what's the period? All right, so then we got to sketch this thing. Its maximum is at pi over 2. In other words, this spot right here is pi over 2, and that's where it hits the max part of the wave. The next maximum is at pi. Do you get that both sine and cosine, when they're all done, they finish in the exact same place they started? So this could be cosine or sine. It says sinusoid, but its highest spot is like this, and its lowest spot, it doesn't even tell us. It just tells us that these are two maximums. Here's a maximum, and here's a maximum, and here's the next maximum. Okay, so there. Could it be shifted down or up? Yep, doesn't matter. The question now is, what is its period? It finishes up one full cycle, which is from the top to the top, or from the bottom to the bottom, or from the middle to the middle. Anyway, it finishes up this full cycle from here to here in that long. Normally, you'd say it was 2 pi, but this one's period is definitely not 2 pi. It's this one minus that one. Do you get if we had a normal sine function and it looked like this, and this is 2 pi? Where it finished, I know it started here and it finished there. This is 0 and this is 2 pi. Technically, to find the period, you just go 2 pi minus 0. Get what I mean? You take this minus that, and it gives you 2 pi. When your numbers aren't quite as nice, and you have two maximums like this, you take, just like we did 2 pi minus 0 to get a 2 pi period, we take pi minus pi over 2. And pi minus pi over 2 is like pi minus a half of a pi, so it's 1/2 pi. Pi over 2. I know that one was challenging, but it's not super complicated. Take your two maximums, and you take the bigger one minus the smaller one. All right. Here's one, 23, where it says the maximum is at this, and then the next minimum is that. Is that how you complete a full period as you go from the top to the bottom? No. It has to go back up to the top again. So do you get, they've really only told us half of the period? Its maximum was here, and its next maximum is what we were looking for. So anyway, if I make my little picture, my maximum's at pi over 4, wherever that is. And that's the high spot of a sinusoid, so it's going like that, back and forth. And it's actually easier to think of these as above the line. Do it any way you want, but if that's pi over 4, the next minimum's at pi over 2. That's this spot. And if that's pi over 2, normally I said you just subtract this one minus this one, but now that's only half of the period. Do you get the period is when it hits this next spot? All right. So you still subtract pi over 2 minus pi over 4, but then that's only giving you this distance, and you have to figure out It's not complicated. How to get the one full period. Now, since I've showed you 21 and 23, I'd like you to do problem 22. Would you circle number 22? I want you to try number 22 because I did your other homework problems that were like it and you have nothing to practice. And again, how I did it, I made a little picture. Picture's worth 1,000 words. It really does help. So pi over 2 and pi over 4, and I subtracted the bigger one minus the smaller one. But in this case, they'd only given me half of a complete cycle, so I had to double it to get its period. Okay. That was the only tricky thing for the day. So your assignment, odds on this puppy, and I've started it with you. Shouldn't be that bad. Get it done, and I'll look to see how you did on those tomorrow. Then tomorrow's a review, where this is only one little part of it. Remember, there's going to be 8 or 9 questions on the test. You know, it's typically 8. Sometimes if there's R2s are really easy, we give you 8 R2s instead of 4, but 8 or 12 questions that you have to answer on the test. So there's if you're scared about this stuff, the worst it could be is one question like this on the test. So, all right, that's all I got for you for today.